Hello everyone, my name is Christopher Stewart. I work as a product manager at Ericsson. One of the areas that I'm engaged in is the automation of energy efficiency capabilities, specifically for the radio access network. And that is what we're going to talk about now. So we're going to talk about the rApp domain and what we're doing there to find orchestration opportunities as well as efficiencies in the network, making sure that operators end up spending less on their energy and, of course, helping them to reach their sustainability goals as well. So what we're going to dive into is 3 different rApps. The first one is the Energy Performance Orchestrator. So this is a safeguard, making sure that KPIs won't be impacted. So, of course, that is a key concern for the operators when utilizing energy efficient capabilities is what happens to my KPIs. And the Energy Performance Orchestrator helps to mitigate that. The RON Energy Cockpit is a functionality to find inefficiencies in the network, so allowing you to compare the energy consumption between like-for-like sites and like-for-like traffic, and finding, am I as efficient as possible across these different sites? The final thing that we're going to talk about is the Site Energy Orchestrator. So this is not only helping to shave power cost at peak cost hours, depending on the different cost of course the day. It's also helping operators to bring energy back into the network so they can actually make their energy producing assets on site part of the overall energy grid. And that, of course, creates an opportunity to monetize some additional assets that they have already maybe on site today. So we start out with the Energy Performance Orchestrator rApp. So again, it's about saving the operator concern about, okay, if I utilize these energy efficiency capabilities, is there a risk that I will impact my network? What we see is operators are concerned about the impact of utilizing energy efficiency capabilities, and they're therefore not being utilized as well as they could. So one key example is the thinking about the maintenance window, and operators saying, I will only utilize energy assets between maybe 0 and 6 o'clock in the morning. And I will say that this is actually a false pretense. If we look at where we are right now and here in La Fira, the maintenance window starts yesterday at 7 and it is around until 9 in the morning, right? Today, MVC, that ends at 5, so the maintenance window is different. So the ability to utilize rApps will depend on the day. And what we want to help operators to achieve is the full utilization and the optimization of these capabilities while making sure that the risk of impact on KPIs is significantly reduced. So we also see that they choose not to roll out certain features because there is a risk of doing this. And this is all done today in an open loop, so they spend a lot of time analyzing and they spend a lot of time deciding what to do and not to do. So there is clearly an opportunity here for a solution that automates a lot of this entire flow and also automatically helps to find if such cases exist. So what we have built is a closed loop, but an opportunity for it to be open loop as well, where the EPO rApp runs inside of the centralized domain. So of course, that would be the Ericsson Intelligent Automation Platform. And it can look across sites and across the cluster to see if is the utilization of energy efficiency capabilities impacting these KPIs that I'm so concerned with. So if we look a little bit deeper into what this actually means. So this means, let's say, for instance, that I have this cell here. It's an orange cell. And we know for a fact that if impact happens, for instance, because of massive MIMO slip, it might not happen only in the orange cell, or it might not be caused only by the orange cell. It could, in fact, be caused by one of the blue cells. So I could have no energy efficiency capability running in the orange cell, but the blue cells are running massive MIMO slip, and that means that they end up pushing traffic to the orange cell. Well, with the EPO, I can detect the KPI degradation in the orange cell, and I can also correlate that to energy efficiency actions taken in the blue cell. And then I can say, here we need to go in and we actually need to halt the massive MIMO sleep capability if it is, in fact, impacting the overall network. And so the benefits that this brings is, of course, you can break out of the thinking about the maintenance window. You can be more aggressive with rollout because you know that in the back end you have this automatic approach to handle if impact does occur. And you can also be more aggressive in the parameterization of the underlying energy functionality also. So this is the EPO rApp, and then we're going to move on to talk about the Energy Cockpit rApp. And so what this is an ability to look at a like-for-like site comparison, get visualization of the utilization of the underlying energy efficiency assets, and also to see if I have one site configuration here, I have an identical site configuration in another place, and the traffic is very similar, but for some reason I'm consuming different amounts of energy. And then I can start to analyze, is there some underlying issue here that is at play and that is causing this? So the challenges that operators face is to understand the energy efficiency in the network. It is the ability to monitor energy efficiency feature of both the individual hardware assets as well as the whole network. It's the ability to identify with low effort. So again, like trying to make sure that the operational complexity is kept at a minimum, the root cause of network inefficiencies. And it's about to resolve the network inefficiencies with faster speed as well, so that you don't have these underlying inefficiencies for a long time in the network, shaving off and impacting your operational span. So this is actually done with AI. This is a key type of use case where AI is really helpful. Again, it's utilizing this ability to detect certain issues and anomalies in the network, as well as the visualization of radio sites in a map, so that it's easy to use with the graphical interface as well. And so the AI algorithms help to detect and cluster and rank the energy performance of the different sites and different hardware, as well as to isolate faults by finding where you have anomalies with regards to the energy inefficiencies that you might see. And so this is done in a 4-step process, and it's empowering the overall operational teams through, again, the visualization of the radio sites, energy efficiency, again, powered by AI, finding the right metrics to show, and calculating the energy efficiency by rank. It's identifying then the energy inefficiencies based on the underlying rank value, which is visualized in the GUI. And you have automated fault isolation through the help of some predefined algorithms. And resolutions will be provided by the tool and to the CSPs. And if they prefer an open loop, they want to remain in control, then you can keep that open loop open. Or if they want to completely automate that entire workflow, there is the opportunity to fully close the loop and take corrective actions automatically. So if we then move on to the Site Energy Orchestrator rApps, this is the final part of this presentation today and the portfolio that we're showcasing now around energy efficiency and orchestration capabilities. So this is a really interesting one because it not only allows operators to shave operational expenditure through the limiting the spend that they have on energy energy consuming capabilities. It also allows the operators to start provide energy back into the network or by the energy producing assets that they have on site. So that would, for example, be solar panel or wind turbines or something like that. So, of course, the challenges that operators face when it comes to actual spend on energy is the variability of the energy market. And I think we've seen that quite a lot, for example, in Europe, on days where you have low wind or it's cloudy. That means that you end up in a situation where energy prices become really, really high. And this also can, of course, vary with geopolitics as well. And then the RON volumes themselves are, of course, also impacting the operator's energy bills. So you have all of this fluctuation caused by the energy market as well as the RON data consumption too. And we see a lot of stress on the infrastructure from the different energy verticals. And so we can actually alleviate some of that stress through pushing out energy from the capabilities that you have outside. The third one is, of course, the energy consumption of the RAN site. So that is, of course, one of the major spends of the operator in general. And the RAN is the most energy consuming asset that any operator has overall. And of course, there is the strategic mix and market knowledge as well that plays into this. And actually, predictions and AI help a lot in this case as well in order to be able to alleviate that challenge. Right? So the solution is a suite of capabilities and knowledge from varied sources. So it's both the weather forecast, it's information from the energy exchange market, so what are as well as the energy spot market, and the demand response from the RAN as well. So you get outside information coming into the rApp to help it conclude, okay, what should I do based on weather, based on current energy prices, and so on. And you get information from the radio access network as well. So understanding what is the volume of data going to be, what is likely going to be the energy spend in this particular site at this particular time. And I think the benefits are actually pretty easy to see. So of course, it's going to help with automation of energy savings through peak shaving and load shifting capabilities that we have, where you're utilizing the full site equipment. So this is not only related to, again, like the radio and baseband and the RAN hardware, but also the batteries that maybe you have on site, the wind turbines, solar panels, other energy producing or energy storing capabilities on that site as well. We will help to predict the consumption as well as what is the energy source mix going to be, and thereby we can optimize that. And again, the third point here is it's not only allowing you to save, it's also allowing you to monetize all of the assets that you have on sites through, if you set up agreement with the energy companies. And of course, a lot of the energy producing assets that a lot of operators have on site are renewable, so it can actually help the energy grid to be more sustainable as well. So with this particular rApp, there is the opportunity to save energy, there's the opportunity to actually monetize on the energy capabilities, and helping in the overall sustainability journey that we all have to be on. So this is some of the assets or capabilities that we at Ericsson are bringing out in the rApp domain for energy efficiencies. We went through the Energy Performance Orchestrator, helping to make sure that KPIs aren't degraded. Then we talked about the energy cockpit, so finding inefficiencies in the network. And finally, we talked about the site energy orchestrating, helping both to actually save energy for smart utilization of all the hardware assets on site, as well as the opportunity to make money based on those hardware assets on site.